Welcome to The Explainer. Today, we're taking a seriously breathtaking journey, zooming inward and outward through one of the absolute most stunning, yet frankly, most hostile environments in our entire cosmic neighborhood, the Saturnian system. From its majestic, sparkling rings, down to its crushing, gaseous core, and then back out to an incredible array of potentially life-harboring moons, Saturn is a world of extreme, mind-bending contrasts. And understanding this giant doesn't just teach us about one beautiful planet. It actually helps us comprehend the entire architecture and the origins of our whole solar system. But right before we dive in, think about this for a second. What if Saturn's brilliantly pristine rings are actually just a massive 4.5 billion-year-old illusion? For years, scientists were totally convinced the rings were relatively young, maybe only 400 million years old or so, mostly because they look so incredibly clean. But a brand new study from the Institut de Physique du Globe de Paris completely challenges that long-held belief. It turns out we might have been completely fooled by their pristine appearance. Section 1. The Crown Jewels Rings. Let's take a closer look at Saturn's ring system. So Saturn is undeniably considered the most beautiful planet in our solar system, and that's largely because of this complex, shimmering halo. These magnificent rings extend outward up to 282,000 kilometers from the planet. That is an unimaginably huge distance. But here is the mind-blowing part. Despite being wider than several Earths placed side by side, they are typically only about 10 meters thick in the main rings. 10 meters! And they're composed of 99.9% pure water ice. So it's essentially a massive, flattened, shimmering glacier just orbiting a gas giant. Now you might be wondering, how does something sitting out in the dirty, dusty environment of space stay so incredibly clean? Well, that's where that new IGPG study comes in. It brilliantly illustrates this kind of thermodynamic self-cleaning mechanism. Here's how it works. Step 1. Dark, dusty micrometeoroids out from the Kuiper belt strike the icy ring particles at an intense velocity of 20 kilometers per second. Step 2. This extreme high-speed impact completely vaporizes the micrometeoroid, literally turning it into a hot plasma exceeding 10,000 degrees Celsius. And finally, step 3. Because this resulting plasma is ionized, Saturn's incredibly powerful magnetic field basically grabs those dark impurities and forcefully ejects them, either pulling them down into the planet or just tossing them out into space. This dynamic self-cleaning mechanism is exactly why the rings look so young, even if they formed 4.5 billion years ago alongside the planet itself. Moving right along to Section 2. A hostile, gaseous giant. Let's head beneath those rings. At first glance, right, Saturn looks like this calm, peaceful golden sphere, but its composition is actually wild. Its average density is just 0.687 grams per cubic centimeter. Like its larger neighbor Jupiter, Saturn is mostly made up of hydrogen and helium. But even though this gas giant has a mass 95 times greater than Earth, its density is bizarrely low, lower than liquid water, in fact. So to put that into perspective, if you could somehow construct a bathtub large enough to hold it, the entire planet would literally float. It's the only planet in our solar system that can boast that fun little fact. But hey, do not let that light, airy density fool you into thinking it's a gentle world. Saturn and Earth are vastly, vastly different environments. On Earth, we have a habitable rocky surface, and our absolutely most devastating hurricane winds max out around 110 meters per second. Saturn? Yeah, it has no solid surface whatsoever. Its upper equatorial winds whip around at an astonishing 500 meters per second, or about 1,800 kilometers per hour. If you tried to travel through Saturn's atmosphere, a descending spacecraft wouldn't just land on dirt. It would be plunged into this abyss where gases become hotter and denser until the probe is quite literally crushed and melted. Deep down, the pressure is so extreme, it squeezes hydrogen gas into a liquid metallic hydrogen layer that envelops a super dense core of rock and ice. Section 3, the Northern Polar Hexagon. Let's talk about some bizarre polar storms. So when our robotic probes finally mapped Saturn's North Pole, they found something completely unexpected. A massive, perfectly six-sided jet stream. To understand how a geometric shape forms in a swirling fluid gas giant, we need to talk about a concept called evanescence. I know it sounds super technical, but it's basically an atmospheric fluid dynamic process where the strength of a wave decays with height, but it persists just strongly enough to reach up into the stratosphere. This mechanism essentially traps wave information in the cloud tops, and that is what shapes the storm into this massive 30,000-kilometer-wide hexagon. And right smack at the center of this incredible hexagon is a hurricane-like vortex featuring an eye 50 times larger than a typical Earth hurricane. Think about it like this. On Earth, our jet streams are chaotic. They slither all around because our towering mountains, landmasses, and oceans constantly disrupt the airflow. But Saturn is incredibly uniform. It has no solid surface to break up those winds. So, left unchecked, the fluid dynamics naturally settle into this perfectly ordered geometric pattern. It just goes to show how, under the right conditions, nature absolutely prefers stunning symmetry. All right, Section 4, Moons and the Search for Life. Let's explore these astrobiological frontiers. Saturn's immediate neighborhood is absolutely bustling with activity. Get this, as of March 2025, Saturn has an unbelievable 274 confirmed moons. It is essentially its own miniature solar system. And these aren't just, dead, cratered rocks floating out there in the void. They are highly dynamic, diverse worlds that represent some of the solar system's most exciting astrobiological frontiers. If we want to find alien biology, or at least the chemical precursors to it, this is precisely where we need to look. Let's compare the two heavy hitters here. On one side, we have Titan. It's the only moon we know of with a thick, smoggy atmosphere, and remarkably, it has Earth-like liquid cycles. But instead of water, Titan has actual lakes and river systems made of liquid methane. Crazy, right? Then, on the other side, we have Enceladus. It's a much smaller icy moon, but underneath its frozen outer crust hides a global subsurface ocean of liquid water. Enceladus actively shoots massive geysers of water and organic compounds straight out into space, which actually freeze to form Saturn's E-ring. Both of these totally unique environments are prime targets for finding organic compounds. Section 5, Cassini's Grand Finale, the end of an incredible era. Our knowledge of Saturn expanded super rapidly over just a few short decades. We started with some quick flybys from Pioneer 11 back in 1979, and then the Voyagers in the early 80s, which actually first spotted the complexities of the rings and that wild polar hexagon. But the true game changer, that was 2004, when the Cassini spacecraft finally arrived. Cassini orbited Saturn for an unprecedented 13 years, experiencing a full change of Saturnian seasons. It totally revolutionized our understanding, mapped the moons, and even dropped the Huygens probe right onto the surface of Titan. But, all good things have to come to an end. In 2017, running dangerously low on fuel, the mission reached its dramatic conclusion. Cassini performed 22 absolute nail-biting ring dives. It literally threaded the needle right between the planet and its innermost rings, an area we had never, ever explored before. It plunged through the upper atmosphere to map gravity and magnetic fields with unprecedented resolution before deliberately burning up like a meteor in Saturn's sky. Now, you might be wondering, why intentionally destroy such a wildly successful machine? Well, it was to protect those pristine, potentially life-harboring moons like Enceladus from any stray Earth microbes that might have hitched a ride. Cassini left us with an absolute wealth of data. ESA project scientist Nicholas Altobelli summed it up perfectly, saying, Saturn's northern hexagon is an iconic feature. To discover that it still holds major mysteries is very exciting. We sacrificed the probe, for sure, but the data it returned in its final moments will feed scientists for decades to come. Which leaves us with a pretty provocative final thought. What will our next descent into the Saturnian system reveal about the origins of our very own world? Gas giants like Saturn played a massive role in shaping the architecture of our entire solar system, steering asteroids and dictating exactly where smaller planets formed. By understanding Saturn, we basically unlock the secrets of planetary formation, and we get a glimpse into what gas giants might look like around other stars. With future missions like the Dragonfly rotorcraft heading to Titan in the coming years, the mysteries of Saturn are far from exhausted. Thank you so much for joining me on this explainer, and keep your eyes on the stars.